Welcome to Unit 11 and one of my favorite topics, which is called probability. Probability is one of my favorite topics because it affects all of us. Everywhere you go in life, you are affected by probability or the chance that something happens. For instance, what's the probability that it snows today? What's the probability the sun comes out? What's the probability you pass your test? What's the probability you win the lottery? What's the probability that we get or contract a contagious disease? Everything you do is affected by probability and the chance that something happens. Now, probability can be expressed in three ways. It can be expressed as a fraction, it can be expressed as a decimal, or it can be expressed as a percentage. And we're going to do three brief examples, and we're going to talk about notation, mathematical notation. First of all, rolling a die. If I want to know what is the probability that you roll a die once and get a number less than 3, this is how it's expressed notation-wise mathematical. Capital P is for probability, and inside the parentheses is the event that you want to happen. What's the probability you get a number less than 3? Well, in fraction form, the bottom number is always the total number of outcomes. Well, when you roll a die once, there are 6 total outcomes, and on top goes the number of ways the event in the parentheses can occur. Well, how many ways can you get a number less than 3? Well, there are 2 of them, a 1 and a 2. So therefore, the probability of rolling a number less than 3 is 2/6, which we always reduce our fractions, which would be 1/3. As a decimal, you all know that's 0.3 repeating, and to change that to a percent, you move the decimal 2 spots to the right, and that would be 33.3%. Flipping a coin. What's the probability that you get tails? That's what the notation would look like. T for tails. Obviously, we all know there are 2 total outcomes on a die, or on a coin, and only one way you can get tails. So the probability is a half. The decimal, obviously for a half, is 0.5, and if we move the decimal 2 to the right, that is 50% chance that we can flip tails. Drawing cards. What's the probability that you draw an ace on one draw? Well, there are only 4 aces in the deck, and I hope we know without the jokers there are 52 total cards. 4 out of 52 is the probability that I get an ace on one draw. If I divide 4 by 52, I get a decimal of 0.077, which is the same as 7.7%. Obviously, that is the smallest chance of any of these 3 events, and that's how you compare them. That's probability, the probability basics. Now, we're going to talk about finding this bottom number right here. There are 3 ways that you can find the bottom number. First way is called the fundamental counting principle, FCP, which is what I'm going to call it from now on, FCP. FCP is a method for finding total number of outcomes. I'm going to do one example for you right here. If you need to pause the video, please do. How many ways can you buy a sub from Subway if you have 4 meat choices, 5 bread options, and 3 cheese options? Well, when you use the fundamental counting principle, it involves multiplication. Basically, FCP says you multiply all your choices together. Well, we have 4 meat choices, we have 5 bread choices, and we have 3 cheese choices. If you multiply all those numbers together, you will find there are 60 total subs or ways that you can buy a sub from Subway if those are your options. And that's it, people. That's basically what FCP says. If you have questions about that, please ask during class. The other 2 ways for finding the total number of outcomes, permutations and combinations. A permutation, what is it? Well, by definition, a permutation is the number of ways to put things in order. The key phrase, people, for permutations that you need to write and highlight in your notes is that order matters. The things have to be in order. A combination is the number of ways to select and I'm going to put this in quotes, a group of things, whatever those things may be. People, marbles, gumballs, etc. The key with combinations is order does not matter. Does not. That's the difference between the two words, permutation and combination. Now let's talk about the formula, or the mathematical way to calculate this. On your calculator for permutations, you'll see little n, capital P, little r, which capital P means permutation. Now what does that mean? That means basically you take the total number, which is n, and you divide it by n minus r. N factorial divided by n minus r factorial. Now you may or may not have seen what that exclamation point means. Well, what does factorial mean? If you don't know what that means, it's basically the product of all natural numbers from n, the total, down to 1. That's basically what factorial means. So, if for instance you see 5 exclamation point, 5 factorial, all that means is take 5 times 4 times 3 times 2 times 1. You start with n and you go down to 1, very simply. If I ask you, for instance, what 3 factorial is, n is 3, so that's just 3 times 2 times 1. That's what factorial means. So when you see that symbol, that's what you do. The formula for combinations is little n, capital C, little r, which means n factorial divided by r factorial divided by n minus r factorial. And I can show you how to do that on your calculator during class, so make sure you ask if I don't do that. Now, how do you tell the two situations apart when you're doing word problems? There are key words to use for permutation. If you see the word order, or the word arrange, or if you see the word place, or if you see the phrase lined up, or pick one at a time, or if you have places, titles, or positions, all these things in a word problem would indicate permutation. Combination is much simpler. It would say the word group, collection, or sets. Those things indicate a combination problem. And the key about combination, since this r factorial is on the bottom and not in the permutation, combination answers are always smaller than permutation answers if n and r are the same number. Combination will always be smaller. Pause the video if you need to write that down. All right, let's talk 2 examples. Example number 1. Katie is going to adopt kittens from a litter of 11. She's going to take 3 home. How many options of 3 does she have? Well, in order to do this, you've got to ask yourself the key first question. Does order matter? And in this particular situation, there are no words in this problem that indicate permutation. All it says is how many options of 3 does she have. So therefore, order does not matter, and this is a combination problem. So therefore, I do NCR, where n is the bigger number, the total number of options I have, which is 11, and I'm going to pick r, which is 3 of them. So therefore, on my calculator, I can type in 11C3, which is 11 factorial divided by 3 factorial times 11 minus 3 factorial. You could type all that in your calculator, or I can tell you the answer. And the answer for this, if you type all those things in, is 165 ways. She's got 165 ways to take 3 kittens home out of a group of 11. Example 2. How many ways can a stylist arrange 5 of 8 vases on a shelf from left to right? Well, again, ask yourself the first question. Does order matter? Is there anything in the problem that indicates these things have to be in order? And the answer is yes. There's the word arrange, and we're going from left to right. 2 dead giveaways that this is a permutation problem. NPR. Well, n is the grand total, which is 8. So this would be 8 choosing 5 items. Well, what does that mean? Mathematically, that is 8 factorial divided by 8 minus 5 factorial. Now, I'm going to show you what that means briefly, just for the sake of knowledge. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is on top. And 8 minus 5 factorial is 3 factorial, which is 3 times 2 times 1. Well, your 3's will cancel, your 2's will cancel, and your 1's will cancel, leaving you the number in the circle. 8 times 7 times 6 times 5 times 4. That is how many choices this stylist has for arranging her vases, which comes out to be 6,720 ways. And that is the difference between permutations and combinations and how you determine that from word problems. If you have any questions regarding this video, please ask during class.